I'm going to start by the first problem, which is a direct application on what we explained in the previous slide. So I have here an arm that is rotating at a rate of theta dot is equal to 4 radians per second. I know theta dot, I know theta double dot, I know theta is equal to 180 degrees. I need to determine the force it must exert on a 0.5 kilograms smooth cylinder if it is confined to move along the slotted path. So guys, this cylinder here, did you see this cylinder? Should move in this path, all right? So there is a slot here, and this cylinder is restricted to move inside the slot, all right? So this cylinder cannot leave the slot, right? So this cylinder can never leave this slot. And I have an arm, this is the arm, and this arm is pushing this cylinder to move, but this cylinder is always moving in this slot. Okay, guys? Guys, you're listening? You listening, guys? All right. So I'm gonna repeat. I have a cylinder that is moving inside this curve, the slot, all right? And I have an arm which is at this angle, it has the same direction of UR. So this is UR, and this is U theta. Now, why I am putting this U theta in this direction? Because this is, in fact, the angle theta, right? So the angle theta is moving counterclockwise, so I put this U theta counterclockwise, right? So this is UR, and this is U theta, and I have a slotted path, and this cylinder is restricted to move in this slotted path. Okay, guys? Now, there is an important sentence here. It is the last sentence of this example, or of this question. They are saying that the motion occurs in the horizontal plane. So guys, as a first impression, if I take a look on this figure, as a first impression, I may think that this is a vertical plane, all right? But the motion here, they are saying that the motion here occurs in the horizontal plane. What does this mean? This means, guys, that if this is my horizontal plane, then this arm and this slot here and this cylinder belongs to this plane, to this horizontal plane. All right? And what is the horizontal? What is a horizontal plane? A horizontal plane is always perpendicular to Z, to the weight, all right? To the gravity. What does this mean? If I want to do the equation of motion, I should draw a free body diagram. If I want to draw the free body diagram in this horizontal plane, what force will not be shown? What force will not be shown in this horizontal plane? The weight. Perfect, Noor. The weight, guys, will not be shown because it doesn't belong to this horizontal plane. So if I am here, if I am at this plane, I'm seeing, guys, I'm taking a section from upside, right? So I'm taking a section from upside. I'm look from upside and drawing this figure. So if I am here in this horizontal, the weight will not be shown. So what I'm gonna do now is to draw the free body diagram of this cylinder, right? So this is my cylinder. What do you think are the forces exerted on this cylinder? What are the forces exerted on the cylinders? Of course, guys, I know that this is UR, and this is U theta. Now, what are the forces exerted on the cylinder? In fact, guys, I cannot show the weight because I am in the horizontal plane, but I know that this arm here is doing a force on this cylinder. Who can tell me, guys, what is the direction of the force exerted by the arm on the cylinder. At this theta, of course, at this moment. At this moment, at this theta, guys, you're listening? In fact, at this position where theta is equal to 180, the force exerted by this arm on this cylinder should be in the same direction of u theta. Why? Because in fact, this force F should be perpendicular to the line of action, it will be perpendicular to this arm, all right? Because this arm, guys, it will be perpendicular to the the common line between this arm and the cylinder. So it will be perpendicular to this line here, which is F. Right? So this will be F. It will be perpendicular to the common line between the arm and the cylinder. Now, guys, what is the second force exerted on this cylinder? The normal force, perfect, Noor. This normal force is the normal force exerted by this slotted path on the cylinder. All right? So I have here a slotted path, in fact. So since I have a slotted path here, then the normal force, guys, should be perpendicular to this slotted path. All right? So it will be perpendicular to the tangent on this path, on the point, and on this path, this will be the normal force, all right? So it will be perpendicular to the tangent on this path. Now, if I want to take the tangent at this point, in fact, this path is doing a vertical tangent here. It has an oblique tangent here, all right? So this means, guys, that the normal force will be perpendicular to this oblique tangent, all right? So this will be the normal force. Now, of course, guys, you can assume any direction, and then from the values at the end of the problem, you can predict if these directions are correct or not. All right? All right, guys? Now, how to do the projection of the normal force on UR and U theta? I need an angle. And I said, guys, previously that the angle psi, the angle between n and u theta, and could be found using this equation. So this will be the angle. This is psi. It is between n and u theta. And this psi is equal to what? It's equal to 10 minus 1 of r over the derivative of r with respect to theta and not with respect to time. Right? So this means, guys, that I should know the equation of r with respect to theta, and it's given here. All right? So r is equal to 2 over theta. And this means, so let's go back to the black color. This means, guys, that r dot will be equal to minus 2. I don't want to find r dot. I want to find now, for the time being, I want to find dr over d theta. So dr over d theta will be equal to the derivative of 2 over theta, which is minus 2 over theta squared. So if you replace this in this equation, 2 over theta over minus 2 over theta squared will be what? Of course, this is 10 minus 1. Sorry, I forget this 10 minus 1. So it will be 10 minus 1 of minus theta. But don't forget, guys, that this should be what? This should be in radians, all right? So psi will be 10 minus 1 of minus theta when theta is equal to 180 degrees, which means when theta is equal to pi. So 10 minus 1 of minus pi will be equal to minus 72.34. This negative sign is basically, because if you go back here, if psi is negative, then it is measured clockwise from the radial line to the tangent. All right? So it is measured clockwise from u theta to n, which is also correct, all right? So it's clockwise, that's why it is negative. Okay, so I know psi, now I can do the projection of the normal force on the on UR or on U theta, okay? So if I go back to the cylindrical coordinates, I know that these are the equations. Let's put them here. These are the equations of forces, or of equation of motion. And then I'm going to put the free body diagram here. And then I can now apply the equations to find F and N. All right? So sum of Fr is equal to what? Sum of Fr is in fact equal to mr double dot. We're not going to repeat it. Mr double dot minus r theta dot squared, which means I need to find r dot and r double dot. So I know that r is 2 over theta, which means that r dot now is versus what? Versus time, all right? So it's different than dr over d theta. So it is 2 theta dot over theta squared. Guys, please postpone your questions until I finish the problem. Right, Batul? Just 1 minute. It is minus 2 theta dot over theta squared, and then this means, guys, that r double dot will be equal to minus 2 over theta 4. I'm going to apply u prime v minus v prime u, right? So u prime will be theta double dot minus v prime, theta double dot v, which is theta squared, minus v prime u, which is 2 theta dot, and I have a dot there, so it will be third. All right, so this will be over theta 4, so don't have to put this line. Okay, now what I'm gonna do is to remove 1 theta with this theta 4, which means r double dot will be equal to minus 2 over theta 3 times theta double dot theta minus 2 theta dot squared. All right, so this is our double dot. Okay, now what I'm gonna do is to I know in fact theta dot and theta double dot from the problem, from the given here, right? So what I'm going to do now is to apply these equations. Let's start by sum of forces in radial directions. What are the forces exerted in radial direction here? F will vanish because it's perpendicular to the UR. So it is, what are the forces, guys, exerted on the radial direction? It is N sine psi, yes. So it is sine psi is equal to M r double dot minus r theta dot squared when theta is equal to 180, which means when theta dot, sorry, this is 180, right? Which means when theta dot is equal also to 3 and theta double dot is equal to 4. They are given, all right? So I'm going to substitute them in this equation. Right? Now the second equation is the equation of sum of f theta. So this is the first equation. The second equation, right, is the sum of forces in theta direction. So what are the forces exerted in theta direction? What are the forces, guys, exerted in theta direction? I have plus F plus N cosine psi. All right, and this will be equal, of course, to m r double dot plus 2 r dot theta dot. And then if you guys substitute theta dot, theta double dot, and r double dot, as well as r and r dot, you're going to have these two values. So you're going to have that n is equal to minus 4.5 Newton, which means I should flip the direction of n. And F is equal to minus 0.898, which also means that I should flip its direction. All right?